All right, today is the 14th, Valentine's Day, 2020, Math 1, and we're talking about arithmetic and geometric recursive formulas. So before we look at recursives, I want to tell you that what we did yesterday were called explicit formulas. So the explicit formula will you look up, I told you not to use computers. Okay, I do need computers because I want you to look up the word explicit.
Leaving no room for confusion or doubt.
Okay, leaving no room for confusion or doubt. What do you have there, Micah? Something like that?
Yeah.
Stated incredibly clearly. The explicit formula, when we're looking at geometrics and arithmetics, is incredibly clear. If you plug in the term, out comes the value. If you want the first term, you plug in a 1. If you want the third term, you plug in a 3. If you want the fourth term, you plug in a 4. If you want the 100th term, you plug in 100. So the explicit formula, I plug in the number and out comes the value. That's the explicit formula. It's incredibly clear. It does exactly what it's supposed to do. It's what you dealt with yesterday. Plugging in 1, 2, 3, 4, getting out the terms. Today we're going to look at the recursive formula. Look up the word recursive. Before you say it, read it to yourself. Nico, recursive, what'd you find?
Characterized by recurrence or repetition. Okay,
this idea of repeating, of doing it over and over again. This idea of kind of circling back. A recursive process is something that I keep going back to it. A lot of life is a recursive process. That you get it wrong, and then what do you have to do? You got to go back to it. Most of your social interactions, you're learning that way. This idea of I keep circling back. So mathematically, for us, recursive is going to be that I keep looking back. So we're going to write it as keep looking at previous term. Recursive means that I keep looking at previous term. Hope you guys are good with the word previous. It's the term that just came in front of me. So if I look at this sequence right here, if I just give you the number 6 alone, you've got no idea what's going on. If I tell you the next term is 10, even there, you really don't know what's going on because you don't know if it's arithmetic or geometric yet. We can say, am I going up by 4 or am I multiplying by like 1.8 or something? I don't know what the 10 over 6, 5 over 3, 5 over 3, 1 and 2/3, 1.66 repeating. Okay, so am I multiplying by 1.66 or am I adding 4? I don't know yet. I need another term to find out. I'm at 14. Okay, so what's going on? Up by 4. Now, I'm hiding it. Up by 4? Okay. You can't see what I'm hiding. What's that term right there? You don't know what's here, but you know it's going up by 4. You don't know what's here. Can you even find that term? No. You don't know what's here. You with me? Even if I tell you that it's going up by 4, if you don't know what was behind it, you can't figure out what's in front of it. So it's going up by 4. Can you tell me it goes here? How did you do that? Did you have to look backwards?
Yeah.
Okay. Can you tell me what's right here? Did you have to look backwards?
Yeah.
Can you tell me what's right here? Did you have to look backwards? What I'm doing right now is recursive. Was it recursive, this whole kind of a cycle thing? Okay, what's right here? Do I have to look backwards? That's recursive. The idea that I keep looking backwards, I keep looking backwards, I keep looking backwards. Explicit, I could have just thrown in, hey, throw in a 7, is that the 7th term? Throw in a 7, get out of 30, right? Throw in a 1, get out of
6.
Throw in a 2, get out of, throw in a 14, or throw in a 3, right? That's explicit. Throw in a value, get a value out. Throw it in, get it out. You can do it totally in isolation. Could you find that term with nothing else if you had the explicit?
Yeah.
Yes, I would throw in an 8 and I'd get out the term. Do you see the difference? Explicit, I plug in the term, I get out the value. Recursive, I keep looking backwards, looking backwards, looking backwards. This is very much a Math 1 lesson today. It's going to feel weird at first. Let your brain go with it, don't trip out. The language of this is right here. This is going in your notes. A sub n minus 1, or f of n minus 1. It's another language. When you see this, you're going to say previous term. That is telling you to look backward. Make sure you have this, and this into your notes. I'm not so super concerned up here. I'm nervous now. Don't worry about writing this. If this, let's go with 4, 8, 12. Cool. Let's call this T sub 2. Let's also call it T sub n. It could be any number you want. I don't know. T sub, pick a number, Nico. Okay, T sub, got it? If this is T sub 2, what is this? T sub 4. I'm going backwards.
1.
Okay. If this is T sub 18, what's this? T sub 17? Oh, see, so if this is the term, I'm looking backwards, right? I'm just going back one term. Okay. If this is T sub n, what is this?
T sub
Minus 1.
Wait. Yeah.
T sub n minus 1. Okay, so if this is the current term, that's the previous term. If this is the current term, that's the previous term. If this is the current term, that's the previous term. Let's take it even further back. If this is T sub 2 and this is T sub 1, what is this? T sub
0.
Okay. If this is T sub 18, this is T sub 17, this is T sub 16. So if this is the current term, this is the previous term, and this is the previous term. If this is the current term, that's the previous term, and that's the previous term. Okay, if this is t sub n, and this is t sub n minus 1, what is this?
T sub n minus 2.
Good. If this is the current term, and this is the previous term, what is this? The previous term. That's going into our notes. That's saying, hey, I need you to look back not just one term, I need you to look back 2 terms to figure out what's going on. All right, so what does this even look like when we're doing the math? Here it is, Gavins. That's plural. These 2 things create this. And it doesn't create it by me throwing in a 1 and getting out a 7, throwing in a 2, getting out a 12, throwing in a 3, 17. Nope, I'm not throwing numbers in. This is not an explicit. This is a recursive. This, if I give you this, you should be able to create this. And here's how it works. What's the value of the first term? 7. I said the value of the first term is 7. I gave that to you. 7. Now, so I'm right here at the second term. This tells me what to do. Ready? What is this saying right here? It's saying, hey, look back at the previous term. Okay, so I'm right here. I look back and I see 7. And this tells me to do what to it? Plus 5. Where am I at? Now I'm right here. So I get right here. And this says to do what? Look backwards. Look at the previous term. I look back. I see a 12. What should I do to it?
Add 5.
I'm right here. I'm at my 4th term. Yes. 17? I jump here. This tells me to do what? What's that saying right there? It's saying, hey, look backwards. Look backwards. Okay, boom, I look backwards. I see a 17. What do I do to it? Add 5. This is the recursive formula. It's based off of me looking back. Now, it's flawed because if I want to get all the way out here to t sub 87, it's going to be a mess. It's going to take, that's why I have the explicit. I like the explicit, but this is a recursive. You're not going to have to go out to 87 with the cursives. Because even if I did, I would actually take the recursive and turn it into an explicit. We'll learn how to do that next week, not today. Let's do one more. This is what you're going to be given. What is the value of the first term? 4. I go to the second term. And it says, what's it tell me to do? Look backwards and do what?
Multiply by 3.
That's exactly what it's doing, Chris. Chris, right here, what is it telling us to do?
Look back.
And then do what?
Or multiply 3 times 4 just to
It's saying look back and multiply it by 3. So I'm right here, I was at 4, I look backwards, multiply it by 3, I'm at 12. I come here. It says look backwards, multiply by 3, I'm at 36. I'm right here, it says look backwards, multiply by 3, I'm at like at 108. Recursive. Looking backwards, looking backwards. Whiteboards and markers, please. here we go. That table, back here. Oh my gosh. Yeah, open up your backpack and get out your marker. I would like to know the first 4 terms of this recursive formula. I will help you. The first term is negative 3. It starts at negative 3, and then where does it go? Give me a couple more terms after that. This is telling you what to do, and you know how to read this. What is this saying right here, Nico?
The previous one.
3 times the previous term. Perfect. Beautiful. Excellent, Gabby. Give me one more term.
First 4.
Excellent. First 4, please.
After negative 4.
I gave you the first one. The first, so up to 4.
Okay.
Beautiful. Excellent, excellent. Show me that board. Got it. The first term is negative 3, and then you raised the last term. You went to 5.
Oh, I think I meant
No, it's not.
4 more.
So find the first 4 terms, and I gave you the first one. You're good.
Oh.
I'm not objecting.
You actually didn't.
Yeah, that looks good. Bradley looks good. Everyone happy here? Good? Good? Dude. Sorry, guys. I can't handle it. I choose not to. Okay, so you're here. I choose not to. It's a choice. It's like I'm choosing to sit down. Yeah, you see what I'm doing. You guys get it?
Yes.
Okay, if I move those? Okay. Number 2. Give me the first 4 terms. Jackson, I've given you the first one, so I need 1, 2, 3 more. Cool. But give me this one on your board. Write down, start with the 13. Perfect. Good. Good, good. Good, good, good. You know what, can I have your board? I'm gonna show it to the people at home, my viewing audience. So we started at 13, minus 6, minus 6, minus 6. Look back, take away 6. Look back, minus 6. Look back, subtract 6. Number 3. Starting at negative 7, and what, Jackson, what's it saying? Look back.
Oh, go back there.
Look back and multiply by negative 3. Look back, multiply by negative 3. It's doing something cool too. It should start doing a flip-flop type of thing with the signs. Negative 3. Good. Negative 3. Got it. You're in your fancy markers. So your sign flip-flop got off. So I started at negative 7 times negative 3 giving me a positive 25. And then negative. Once you once you got one term off, it messes everything else up. The explicit wouldn't do that. The explicit, you plug in 2, you plug in 3. So if you mess up 1, the next one would be okay. Yeah. Good. 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 Can I use yours? What's that? Good. Number 4. You know, something's off there. Something's off. That should be. You lost it on So right here, that's where we're off. It should be a negative 8 right there. And notice as soon as you mess up, it's going to mess everything else up. Because I keep looking backwards, and it looks like it's off here. Negative 3 to 2, negative 3 to 2, negative 3 to 2. One more. I'm going to make this one up. And I can do it with A's, I can do it with T's, I can do it with anything. The idea is when I see an n minus 1, I know it's telling me to look back. Let's go with T sub 1 equals, pick a number, Gordon.
8.
Okay. T sub 2 equals, pick a number, Taryn. 12. You ready for this? T sub n equals T sub n minus 1 plus T sub n minus 2.
Oh.
See if you can find me the first 5 terms. I have given you the first 2 terms. What is it telling you to do? What is it saying to do right here?
Go back. One. Pick it up.
Back. What?
20, 20, 20.
No.
Isn't it? Is it this?
Give me one more term. He's right. You're on the right path.
Wait. Oh. But it says only
But it's a moving thing. So as soon as I put a term down, my previous and previous just changed. So right, we have it. Drink it up. How did you do this? You had those two, right? This guy, he says, here. It's not T sub 1. It's T sub n minus 1. It's saying, right here it says, look at the previous term and the previous term. Those two become that guy right there. Okay. Those guys make this one. Those guys make this one. That's it for previous. The 52, well, that's not that. 52, 52. Here, I don't know what that means. Okay. I don't even know what's going to happen, but I'm going to give you one more.
I'm scared. Probably like T n minus 1.
I don't even know.
T n
Can I
minus
choose
2.
the number?
Plus T n minus 87.
Okay. 1, you got it.
Okay.
T sub 1 equals 1. Done. You said just 1.
I don't want to pick the number.
Okay, pick another
But
number.
It's all right. I don't want to complain.
T sub 2 equals.
You're such a liar. Oh, 6. Oh, what the?
No, please no.
I don't even know. 2. Okay.
Why?
You ready?
Wait.
All right. Oh, I don't even know. I don't even know what this is going to do. So T sub n equals T sub n minus 1 times T sub n minus 2 raised to the T sub n minus 3.
I got it. I know what it is. I got it.
I don't even know what's going to happen. Try it out. Try it out. I'm so excited.
How many?
Wait, no, what?
Just give me 5 terms. I've already given you 3. Give me 2 more. Oh, this is exciting.
260.
Oh my gosh. I don't even know what's going to happen.
I know it is.
Those exponents are going to get insane.
I got it.
2.
Wait, no, I don't got it.
I take the T sub 2. I raise it to the T sub 3. T sub 2.
I think I got it.
36.
Mr. Barre, I think I got it.
Did I get it?
Dude, I can't even
Did I-
write it. It's too big of a number.
Anybody agree with that term?
Yeah.
No.
That's
That's not what I know.
Yeah.
What I got?
Yeah, I just
And then the next number is
Oh,
5.
oh my gosh, the next one's gonna be disgusting
I
now.
got 5.706304287 times
So-
10 to the 14th power.
I believe that. 'Cause I'm about to raise something to the 36th power, aren't I?
Wait,
No.
Daddy actually
No,
got an
guys.
answer.
Yeah.
Yes.
No, because you raised it to
Okay,
the
ready?
T-sub.
Read me.
No, to the 6th power.
It says, take the second, this guy right here,
I didn't do that.
square it, right? T sub, oh no, I'm wrong. Oh,
Yeah.
I'm wrong.
See,
Dude, no, I'm
Number
wrong.
1 would be right here.
It would be
number
this.
two would be here, and
Okay.
the 2 would be.
So, give me,
44.
okay, give
The 2 would
me,
be right here.
give me the previous term, 2. Give me the previous
This
term,
would be 6.
6, and give me the previous term.
1.
This would be a 12, you're right.
Yeah, it's a
Oh,
12.
no, but then
One of
the
the next would be 6.
power, which is...
And then
Okay, now the next one, let's keep going, okay.
No, they already did.
So I'm right here. Okay, give me the 12, give me
Chris, you want math?
2 to the 6th.
that should be 768.
My actual is wrong.
That sounds about right.
768.
768,
Yeah.
good, okay, good job, really.
I almost got it right.
Got it.
She's right.
Yeah, no, I got a whack number.
I was doing the wrong, I was putting the wrong numbers in the wrong places.
You were switching the 2 and the 1.
I got like 5 more.
Okay, okay, one more.
Yeah.
Ready?
Yes.
Okay,
Yes.
so I start with what goes inside.
So
768, 12, raised to the second? That's not crazy.
No, Mr. Barre, it should be,
No,
it should
that's
be
right, yeah.
12 times 2 raised to the.
It should be, oh, no, because I have this term. So this is saying, look back 1. So Jackson, that guy is that
I
guy.
got the answer. Wait, then let's
Yeah,
go
that goes
back.
there. 12 would go right here.
And then go back 2. That puts it right here. And then go back 3 for the
Right
exponent.
there.
So 144 times 7.
Yeah, I got 110,592.
100, yep.
I got 191.
0, 5, yeah.
Okay.
Can we keep on going?
No. This is well beyond what I need you to be able to do today. But that's fun to play with it, yes.
This is T sub, or not T sub n minus 1. Should it be, because you start at 768, should it be the, no, behind it, or is it just?
So
It's the one
this
right,
is
that's the one right
one
behind
back.
it.
So if this is the current term, if this is T sub n, this is n minus 1, n minus 2, n minus 3. It's saying n minus 1 is the one right behind it, n minus 2 is 2 behind it, n minus 3 is 3 behind it.
So will T sub n, or T sub n minus 1 would be, it'd be behind the 768.
So are we looking at this?
Oh,
So
well,
if,
for the 11,000, or 11,
for this guy?
for that one.
So if this is what I'm looking for, if this is T sub n, this is T sub n minus 1, this is T sub n minus 2, and that's T sub n minus 3.
Because that's
Well,
how
you
many
put
back.
768 for T sub n minus 1. Wouldn't it be 12?
But no, it was T sub n.
Because it changes
So
each
it
time.
keeps changing each
Yeah.
time.
But it changed from 12 to 768, and you still said it was T sub n minus 1, and then it changed from 768 to the next number, and you said it's T sub n.
So it after every time I add a new number, everything changes.
Everything goes up.
So-
So when we added 768 a new number, it
So
didn't.
when we first started, when I first got the problem, this was T sub 1, 2, 3. So right away, this was T sub n. When I very first started, this was T sub n. This was T sub n minus 1, T sub n minus 2, T sub n minus 3. That's where we started. Then we got this number. This number became T sub n. What's this then? T sub n minus 1, T sub n minus 2, T sub n minus 3. And this actually becomes T sub n minus 4 at that point.
Well, then that's what happened, but then when we went to T sub n minus
But-
1 for the equation, we used 768 instead of 12.
It depends what term do I have? Which, Which term do you want me to erase?
The last one.
This guy? Okay, this guy is gone. Is this what I'm looking for?
Yeah.
Okay, I'm gonna find this. This is now t sub n. This is then t sub n minus 1. This is t
Oh,
sub...
so when you already find it, then it's T sub
Then
n.
it, we can.
Oh, never mind.
So
Because T n
it
is the one
keeps
you're trying to
moving.
find.
This idea, t sub n minus 1 is not a constant. It's not a fixed place. It changes. As soon as I take a step forward, everything behind me changes what it was. Like, right now, if I'm t sub n, here, I need some people. This is, I need this group, come up here. Okay, let's see if they can do this. Line up. Good. You guys go over there. Boom, boom. Okay, ready? Your name is t sub n. What's your name? T sub n minus 1. Okay, come in here. Ready? Your name's t sub n. What's your name? What's your name? Okay, boom. We just use them to make you. You exist now. You're t sub n. What's your name?
T sub n minus 1.
Good?
T sub n minus 2.
Good.
T sub n minus
Good. And now I used all of them, and now I exist because I used the formula. I am now t sub n. What are you?
1. T sub n minus 1. T sub n minus 2. T sub n minus 3. T sub n minus 4.
So it keeps changing. As soon as I get a new value, all the numbers behind me change who they are. They don't change their values. They are still those values, but they're t sub n's. She's the previous term. But now if I go away, they all change back. You're t sub n now. Go away. Now what are you?
T sub n.
What are you?
T sub n minus 1.
And what is she?
T sub
Kind of makes sense? I know it's tough, man. I know this is big for your
I
brains.
thought I had an analogy, but then I was like, never mind.
Man, I thought I had an analogy too. Then it ran away.
Yeah.
Sad. Okay, take a seat. Start working. You got the rest of the period.